This is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about biodegradable polymers. So what is biodegradable polymers? Generally, polymers means poly means many, mer means parts. So many parts combine to give polymer. Already we know that previous classes we discussed already. So here biodegradable polymers. So what is the difference between normal polymers and biodegradable polymers? Generally polymers do not undergo biodegradation. These polymers do not undergo biodegradation. Even after long time, it takes lots of time for degradation some of the polymers, and most of the polymers do not undergo any degradation after long time. So it is very difficult to manage the polymer waste in the environment. It is very difficult to manage the polymer waste in the environment. So to avoid this problem, we are using biodegradable polymers. Generally, most of the polymers do not undergo degradation after a long time. Only few polymers undergo degradation, but it also takes lot of time. But it causes so many environmental factors to manage. It is very difficult to manage the polymer waste in the environment. So to avoid this problem, we are using biodegradable polymers. So in this, what are the main advantages of these biodegradable polymers? They degrade quickly. And do not cause such environmental problems. These polymers are degrade quickly and do not cause such environmental problems. So this type of polymers are called biodegradable polymers. So how can we define these biodegradable polymers? So these biodegradable polymers are polymers which undergo degradation. These polymers which undergoes degradation by the naturally occurring microorganisms. By the naturally occurring microorganisms, that means such as algae, fungi and bacteria, etc. So biodegradable polymers means these polymers easily undergoes degradation, do not cause such type of environmental problems. So these are degraded by natural occurring microorganisms such as, for example, algae, fungi, bacteria, etc. So this is the main difference between normal polymers and biodegradable polymers. So normal polymer takes lot of time for degradation. It causes so many environmental problems. It is very difficult to manage the polymer waste in the environment. So to avoid the problem, we are using biodegradable polymers. So these polymers easily undergoes degradation by enzymatic reactions or naturally occurring microorganisms like algae, fungi or bacteria, etc. So these polymers are called biodegradable polymers. So now let's discuss classification of biodegradable polymers. So these biodegradable polymers can be classified into various ways based on their origin, chemical structure and application point of view. So these biodegradable polymers are classified into different ways. It is based on synthesis, origin, structure and application oriented. These polymers are classified into various ways. So first one is based on origin. Based on origin, these biodegradable polymers are classified into two types: natural biodegradable polymers, synthetic biodegradable polymers. So what is the meaning of natural biodegradable polymers? Generally, these polymers derived from natural sources. These polymers are derived from natural sources such as plants and animals and microorganisms. So based on origin, these biodegradable polymers are classified into two types: natural biodegradable polymers, synthetic biodegradable polymers. Here natural biodegradable polymers means these polymers derived from natural sources. So what are the natural sources? For example, such as plants, animals and microorganisms. For example, it's including cellulose, starch, proteins like collagen and gelatin. So these polymers generally derived from natural sources such as plants, animals microorganisms. It's including cellulose, starch, proteins, etc. Best example, you see the image. So best example of starch is the best example of natural biodegradable polymer. Now let's go synthetic biodegradable polymers. Synthetic biodegradable polymers. So these polymers, these are also called as man-made polymers, which are prepared in laboratory. So the synthetic biodegradable polymers these are also called a man-made polymers designed to be biodegradable. These are the biodegradable polymers. These are also called as man-made polymers, which are synthesized in laboratory, and these are designed to be biodegradable. That means easily undergoes degradation, do not cause such environmental problems. So this type of biodegradable man-made polymers are called synthetic biodegradable polymers. For example, polylactic acid. For example, polylactic acid or PGA, polyglycolic acid. So the best example of synthetic biodegradable polymers. Next, second one is based on chemical structure. Based on chemical structure, these biodegradable polymers are classified into two types. Aliphatic biodegradable polymers and aromatic biodegradable polymers. Aliphatic and aromatic biodegradable polymers. These are classified based on chemical structure. Aliphatic, that means straight chain. Aromatic, like cycled. So here, first one, aliphatic biodegradable polymers. So these polymers consist of linear carbon chains. These polymers consist of linear polymer chains, linear carbon chains, and are typically more biodegradable polymers, more biodegradable than aromatic polymers. So generally, aliphatic biodegradable polymers means these are consist of linear carbon chains. Linear carbon chains. So the structure is called, this type of polymers are called aliphatic biodegradable polymers. Best example, polylactic acid, polyglycolic acid. So these are having linear carbon structure. So second type is aromatic biodegradable polymers. So these polymers containing aromatic rings, ring type structure. So these are aromatic biodegradable polymers. These are containing aromatic rings in their structure and are generally less biodegradable compared to aliphatic biodegradable polymer. These are less biodegradable. So for example, PBAT. So that means polybutylene adipate coterephthalate. It's the best example of aromatic biodegradable polymers. So based on chemical structure, these biodegradable polymers are classified into two types, aliphatic biodegradable polymers and aromatic biodegradable polymers. So aliphatic biodegradable polymers means these polymers consist of linear carbon chains. Linear carbon chains, and these are undergoes degrade easily compared to aromatic biodegradable polymers. It takes less time for decomposition. For example, polylactic acid, polyglycolic acid. And second type is aromatic biodegradable polymers. These polymers containing aromatic rings in their structure. And it takes for degradation lot of time compared to aliphatic biodegradable polymers. It takes more time compared to aliphatic biodegradable polymers. Next, third one is based on degradation mechanism. Based on degradation mechanism. So these biodegradable polymers are classified into three types. So they are classified into three types based on degradation mechanism. So in this case, first one is hydrolytically degradation polymers. Hydrolytically degradation polymers. So in this case, these polymers break down through hydrolysis. Hydrolytically. So this type of polymers break down and undergoes decomposition through hydrolysis. Typically in the presence of water or moisture, because these are degraded by hydrolytically. That means hydrolysis reaction. That purpose we are using water or moisture. Example, polylactic acid, polyglycolic acid. And second type is enzymatically degradable polymers. Enzymatically degradable polymers. So these polymers specifically designed to be broken down by enzymes. So enzymatically degradable polymers means these polymers are degraded or decomposed by enzymatic reactions. So these polymers specifically designed to be broken down by enzymes present in the biological systems. Present in the biological systems. For example, it's including polyhydroxylonides, PHA, which can be broken down by lipase enzyme. Lipase enzyme. This type of polymers easily undergoes degradation by enzymatic reactions. So such type of polymers are called enzymatically degradable polymers. And third type is photodegradable polymers. Photodegradable polymers. So in these polymers degrade when exposed to photodegradable, that means in the presence of heat and light. It exposed to light. So making them suitable for application where controlled degradation is required. This type of polymers degraded in the presence of light. So for example, polyethylene, polypropylene or polyvinyl chloride, polymethyl methacrylate. So this type of polymers degraded by in the presence of light. So based on degradation mechanism, these biodegradable polymers are classified into three types. First one is hydrolytically degradable polymers. So that means these polymers easily undergoes degradation by through hydrolysis. That means water or moisture effects on that for degradation. And second type is enzymatically degradable polymers. So this type of polymers undergoes degradation by enzymatic reactions. And third one is photodegradable polymers. So this type of polymers undergoes degradation by the reaction of in the presence of light or exposed to light. So this type of polymers easily undergoes degradation. And fourth one is based on application. So based on application, these biodegradable polymers are classified into three types. So based on application, which field we are using these polymers, biodegradable polymers. So based on that, these polymers are classified into three types. So first one is medical biodegradable polymers. Medical biodegradable polymers. So in this case, this type of polymers, these polymers are used in medical devices. These polymers are used in medical devices. This means drug delivery systems and tissue engineering. These polymers are used in medical devices, drug delivery systems and tissue engineering, where biodegradability is important to minimize foreign material in the body. Biodegradability, it easily undergoes degradation. So where biodegradability is important to minimize foreign material in the body. So in that case, we are using this type of polymers. For example, polylactic acid. For example, polylactic acid or polylactic glycolic acid. Polylactic glycolic acid and polycarprolactone. So all of which are biodegradable, have been used in carry anti-cancer drugs. This type of drugs are used in used as anti-cancer drugs. So first one is based on application. These polymers are classified into three types. Just now we discussed already. So what is the first type based on this application? Medical biodegradable polymers. So these biodegradable polymers are used in medical applications or medical devices and drug delivery system and also used in tissue engineering. So here where biodegradability is important to minimize foreign material in the body. For example, polylactic acid or polycaprolactone. So such type of biodegradable polymers used as a anti-cancer drugs. Anti-cancer drugs. So second one is packaging biodegradable polymers. Second type is packaging biodegradable polymers. So this type of polymers used in eco-friendly packaging do not cause any environmental effects or harmful effects. So in this, these polymers used in eco-friendly packaging materials to reduce plastic waste. To reduce plastic waste. For example, in this, it's including these biodegradable polymers and bags made from polylactic acid or starch-based polymers. These are the natural polymers. Starch, cellulose, etc. These are the natural polymers. So these biodegradable polymers also used for packing purpose we are using because these are eco-friendly, do not harmful effects on this environment or our health also. So that's why we are preferred for packaging food materials or any other. For example, here biodegradable films and bags made from polylactic acid. And next third type is agricultural biodegradable polymers. Agricultural biodegradable polymers. So in this, these polymers used in agricultural applications. These are used in agricultural applications such as mulch films. Mulch films. Mulch films means these are from see this image. Here mulch films means these are the plastic films of used to modify soil temperature. You see this? These are mulch films used to modify soil temperature, prevent moisture growth and limit weed growth. Any unnecessary plants growth also it stops by using this type of polymers and improve crop yield. This is called mulch films. The mulch films means these are the plastic films often used to modify soil temperature, prevent moisture growth and limit weed growth and improve crop yield. And also use seed coatings. To reduce environmental impact. To reduce environmental impact. So this in this image it clearly shows that by using this agricultural biodegradable polymers for what purpose? To improve crop yield. So based on applications, these biodegradable polymers are classified into three types. First one is medical biodegradable polymers. So such type of polymers used in this medical application purpose, that means medical devices, delivery systems and tissue engineering. We are using this type of medical biodegradable polymers. For example, polylactic acid or polycaprolactone. These are used as anti-cancer drugs. So these are the medical biodegradable polymers. And second one is packaging biodegradable polymers. Packaging biodegradable polymers. So these polymers mainly used in eco-friendly packaging materials. For what purpose? To reduce the plastic wastage. For example, here it's including biodegradable films or bags which are made up by polylactic acid or starch-based polymers And third type is agricultural biodegradable polymers. So this type of polymers used in agricultural applications. So what is this agricultural applications such as mulch films and seed coatings to reduce the environment impact. So what is the meaning of mulch films? These are the plastic films often used to modify soil temperature, prevent moisture growth and limit weed growth and also improve the crop yield. That purpose is preferred mostly these polymers in agriculture. So it is often used to growing fruits and vegetable crops over large areas. The most preferred in growing fruit and vegetable crops over large areas. In that case, we are using most prefer this agricultural biodegradable polymers. For example, it's including biodegradable polyesters, and also another example is starch-based materials. Now let's discuss what are the advantages of biodegradable polymers. These are cheaper than normal polymers. Budget friendly, simply says these are cheaper than normal polymers, and it emissions less carbon dioxide, or emission of carbon dioxide is reduced compared to normal polymers, and it takes less time to break down. It takes less time to break down compared to normal polymers, and it is good to the environment, eco-friendly, do not cause such environmental problems, and these are non-toxic. That's why we are using for packaging purpose also, and agriculture purpose also, and medical field also we are using this. And it is easy to recycle. It's the main advantage. It takes very less time for decomposition. These polymers are easily degraded by natural occurring sources such as microorganisms like algae, fungi, microorganisms, etc. Now let's discuss polylactic acid preparation properties, uses of polylactic acid. So it is an important biodegradable polymer. So here this polylactic acid, it is derived from renewable sources. Renewable sources, that means reproduced from nature. These are reproduced from nature. So this polylactic acid is the most important biodegradable polymer, and it is derived from renewable sources such as starch, sugarcane, etc. So this polylactic acid, it is obtained from renewable sources such as starch or sugarcane. So this polylactic acid is a biodegradable and bioactive thermoplastic polymer. This polylactic acid is the biodegradable and bioactive thermoplastic polymer. So what is the meaning thermoplastic polymer? Soft on heating, hard on cooling, and we can remolded. And these type of polymers are formed by addition polymerization. The type of polymers are called thermoplastic polymer. Here polylactic acid is a biodegradable, that means easily undergoes degradation by enzymatic reactions or microorganisms. It takes less time for degradation, and bioactive, very active, and it is a thermoplastic polymer, reused polymer, a remolded polymer. So that has gained significant attention as an environmentally friendly alternative to traditional plastic. That means simply we say it is eco-friendly, do not cause such environmental problems. So it is commonly used for variety of applications due to its biodegradability. Biodegradability means easily undergoes degradation. It takes very less time, and eco-friendly, environmental friendly polymer. So based on this its properties, biodegradability and biocompatibility. Biocompatibility means we are using different fields. For example, medical fields we are using most preferable polymers. These are. So based on this properties, biodegradability and biocompatibility, so these type of polymers are used in variety of applications, and renewable origin. Based on this biocompatibility and biodegradability and renewable origin, because these are obtained from renewable resources such as starch and sugarcane. So that's why this polymer preferred in variety of applications. So how can you prepare this polylactic acid or polylactide? So here it is prepared by the catalytic dimerization of lactic acid. Here see this reaction. This is the lactic acid undergoes catalytic dimerization, then resulting the formation of lactide monomer. It forms lactide monomer. How can you prepare this lactide monomer? Catalytic dimerization of this lactic acid undergoes catalytic dimerization, then form lactide monomer. Here water molecule is eliminating, minus H2O. Then form lactide monomer. And next, this polymerization of lactide monomer in the presence of stannous octet. To give polylactic acid. This is the preparation of polylactic acid. So this polylactic acid or polylactate is the best example of biodegradable polymer, and it is obtained from renewable sources such as starch and sugar cane. And it is a biodegradable and bioactive thermoplastic polymer and eco-friendly, do not cause such environmental problems. And it is used in various applications. It is due to its biodegradability and biocompatibility and renewable origin. That's why we have prepared this polymer in various applications. So how can you prepare this polylactic acid? So this lactic acid monomer, this lactic acid undergoes catalytic dimerization, then form cyclic lactate monomer. And then this cyclic lactate monomer, in the presence of stannous octet, it undergoes polymerization, then it forms polylactic acid. This is the structure of polylactic acid. So see here, this is a lactic acid. It undergoes catalytic dimerization. It undergoes catalytic dimerization. In this case, it forms lactate monomer, lactate, cyclic lactate monomer. Then this monomer undergoes polymerization in the presence of stannous octet. In the presence of stannous octet, then it gives polylactic acid. Then it gives polylactic acid. So now we'll discuss what are the properties of polylactic acid. So the polylactic acid exhibits a range of properties that make it suitable for various applications. These are having lot of properties, range of properties. That's why we are using this polymer in so many applications. So first property is biodegradability. So already we know that this polymer is easily undergoes biodegradation. Biodegradation. It takes very less time. So polylactic acid is the biodegradable under the right conditions. So making it an environmentally friendly material. So it takes less time means it will not cause such environmental problems. So it easily undergoes degradation. This is the main advantage of this polylactic acid. So what is the first property? Biodegradability. And second one is biocompatibility. So it is safe for use in medical applications, medical devices, and also used in food contact applications, packaging purpose also we are using due to its biocompatibility. So mainly these polylactic acid biodegradable polymers having biodegradability and biocompatibility properties. So that's why we are using so many applications like medical devices, packaging purpose, we are using so many agriculture purpose also we are using these polymers. And transparency. So this polylactic acid is transparent and it can be made into clear glassy product. Clear glossy products making purpose we are using this polylactic acid because it is a transparent. So that can be used to it can be made into clear glassy and clear glossy products. Next, renewable resource. So this polylactic acid derived from renewable resources such as sugarcane, starch, corn, starch, sugarcane. So it is a renewable biodegradable polymer. It is obtained from renewable resources such as starch, sugarcane, corn, etc. And rigidity. So it offers good rigidity and it can be engineered. It can be engineered to be similar in strength to conventional plastics. So it is having good rigidity, flexible nature also. So it can be engineered to be similar in strength to conventional plastics. And next one is heat resistance. So this polylactic acid has moderate heat resistance. It has moderate heat resistance, but it may deform at relatively low temperature, limiting its use in high temperature applications. It is limited to use in high temperature applications because it is having moderate temperature. So sometimes we are using in low temperature also, but it limits to use in high temperature applications. And brittleness. So polylactic acid can be somewhat brittle. It's somewhat brittle. So which can affect its use in applications require impact resistance. So last one, barrier properties. Barrier properties. So it has reasonable barrier properties against moisture and gases. It has reasonable barrier properties against moisture and gases. So these are the properties of polylactic acid biodegradable polymer. Mainly biodegradability, biocompatibility, transparency, and renewable sources, and heat resistance, brittleness, and barrier properties. So we prefer more. These are having a lot of range of properties. So we can prefer in suitable various applications. This type of polymer mostly we preferred in so many applications because of this. It is having range of properties. This type of properties. What are the uses of polylactic acid? So these are having this polylactic acid used in so many applications. So first one is packaging. So polylactic acid used for producing biodegradable and compostable packaging. These polymers are used for producing biodegradable and compostable packaging materials such as disposal cups, food containers, and films, because these are not harmful for environment also. So that's why these polymers most preferred for packaging purpose, because this polylactic acid used for producing biodegradable and compostable packaging materials such as disposable cups, food containers, and films. That means these polymers easily undergoes degradation. And second one is textiles. So these polylactic acid fibers used in textile industry. These are used in textile industry to produce biodegradable and sustainable fabrics. So that's why we are using in textile industry also. And medical healthcare. So this polylactic acid used in medical devices such as tissue engineering scaffolds, and drug delivery systems. So these biodegradable polymers are used in medical devices because due to its biocompatibility. So that's why we are using in so many different medical applications. The next one, 3D printing. So this polylactic acid is popular material for 3D printing. So due to ease of use, biodegradability, and availability in various colors. And fourth one is filaments. So it is used in manufacturing of filaments for fused deposition molding 3D printers. That's why we prefer this type of polylactic acid polymers. And biodegradable films. So polylactic acid films are used for agricultural applications. Already we discussed previously. These polymers preferred in agriculture purpose also, such as mulch films. It is used for improve the crop yield, and they can be flowed into the soil after use, improve the soil quality, and improve the crop yields also by using this type of polymers in agriculture. And disposable tableware. So this polylactic acid is used to produce disposable plates, bowls, and utensils for single-use applications, because these are not harmful for environment also and easily undergoes degradation. So this polymer used to produce disposable plates, bowls, utensils for single-use applications purpose. We prefer this type of polymer. And next, consumer goods. So this polylactic acid can be found in consumer goods like toys, cutlery, and cosmetic packaging also we preferred. So this polylactic acid mainly used for packaging purpose and also used in textile industries and also used in medical applications also we preferred mostly. And biodegradable films, 3D printing, filaments, and also used for disposable tableware and biodegradable films and consumer goods. In all these cases, we prefer this polylactic acid biodegradable polymer. Here in this image, it clearly shows that we are using for this applications made up by polylactic acid. So this polylactic acid is used in various applications. And second example is polyvinyl alcohol. It is also one of the best example of biodegradable polymers. Polyvinyl alcohol. It is a water-soluble synthetic polymer. It is a water-soluble synthetic polymer. So known for a versatile and wide range of applications. We are using so many applications. So it is used in various industries due to its unique properties. So it's a polyvinyl alcohol. It is one of the best example of biodegradable polymer, and it is a water soluble synthetic polymer. See here in this image, it clearly shows that polyvinyl alcohol. It is easily soluble in water. So it is a water soluble synthetic polymer used in so many applications because of they are having unique properties, range of properties we are using in so many applications. So how can you prepare this polyvinyl alcohol? So it is prepared by the first polymerizing vinyl acetate, and resulting polyvinyl acetate is converted to polyvinyl alcohol. Here see first vinyl acetate. This is the structure of vinyl acetate. It undergoes free radical polymerization. Free radical addition polymerization. In this case, it gives polyvinyl acetate. Polyvinyl acetate. Vinyl acetate undergoes free radical polymerization, then form polyvinyl acetate. Then this polyvinyl acetate undergoes polymerization in the presence of base NaOH or methanol. Then it gives polyvinyl alcohol. Polyvinyl alcohol. This is the preparation of polyvinyl alcohol. First polymerizing vinyl acetate to give polyvinyl acetate. Then this polyvinyl acetate undergoes polymerization, then form polyvinyl alcohol. Next, what are the properties of polyvinyl alcohol? It is having so many several unique properties, so that make it suitable for various applications. So first one is water solubility. Water solubility. Already we know that polyvinyl alcohol is easily soluble in water. It is water soluble synthetic polymer. So it is highly water soluble, making it ideal for use in aqueous solutions. Next one is film forming. So it can form flexible and transparent films. It is used for preparation of flexible and transparent films to make it useful for coating and packaging materials. These materials are used for coating and packaging materials. And third one is adhesive properties. So in this case, used as a glue or adhesive due to its strong bonding capabilities. That's why this polyvinyl alcohol used as a adhesive or glue, mainly used for packaging purpose. And next, chemical resistance. It is resistant to many chemicals and solvents. It is having good resistance to chemicals and solvents. And biocompatibility. It is considered safe for use in various medical and pharmaceutical applications. Tensile strength. So these polyvinyl alcohol films and fibers have good tensile strength. They are having good tensile strength. That's why we have preferred in so many applications. And low toxicity. So it is non-toxic, which is important for many food. And pharmaceutical application purpose. We prefer this polyvinyl alcohol biodegradable polymers. So what are the properties of polyvinyl alcohol? water solubility. This is the first property. It is soluble in water. That's why we prefer used in aqueous solutions. Second one is film forming. So that's why we are used for coating and packaging materials. And third one is adhesive properties like glue or adhesive. So we mainly use it for packaging purpose because of these are having strong bonding capabilities. And chemical resistance. They are having good chemical resistance with the chemicals and solvents also. And biocompatibility. Due to this reason, we preferred in so many medical applications. And tensile strength. It is having good tensile strength and low toxicity. So it is having it is a non-toxic nature. So it is important for many food and pharmaceutical applications. We prefer this polymer. So these are the properties of polyvinyl alcohol. Next, uses of polyvinyl alcohol. So it is having wide range of properties. They are having several unique properties. That's why we preferred in so many applications. And also used in various industries. So first one is adhesive. So polyvinyl alcohol is commonly used in manufacturing of water-based adhesives because it is a water-soluble synthetic polymer used as an adhesive. So it is preferred in used in manufacturing of water-based adhesives for woodworking, paper and packaging industries. We preferred used as a adhesive. And second one is textiles. So these polyvinyl alcohol fibers are used to create non-woven fabrics and which are used in applications like medical dressings and filters. So that's why we prefer these polyvinyl alcohol fabrics, this material used in these polymers used in textile industries also, which is used in medical applications like medical dressing and filters also. We prefer this type of polymer. And third one is paper sizing. So this polyvinyl alcohol is used in the paper industry to improve the paper strength and printability. Character improve. So that purpose we are using this polyvinyl alcohol in this paper industry also. And packaging films. So these polymers are used in packaging materials, particularly water soluble packaging because it is a water soluble synthetic polymer. So these polymer mostly preferred for packing materials which are used in water soluble packaging such as laundry detergent pods. In this case, mostly we prefer this type of polymers. And next one is medical and pharmaceutical. So this polyvinyl alcohol is used in medical application because of this biocompatibility property. So this polymer is used in medical applications. It's including production of contact lenses, artificial tears, and as coating for tablets and capsules. Purpose also, coating purpose also, we prefer this polyvinyl alcohol. So it is used as a adhesive and textile industry. Some of the use given in this image clearly shows that. So it is used as a adhesive and it is used in textile industry, paper industry and packaging film, non-toxic nature, and it is used in medical applications also, pharmaceutical, medical field also. We prefer this polymer. And also used as a emulsifier. So it is used as an emulsifying agent in the food industry. So particularly for stabilizing oil in water emulsions. So it is used as a emulsifier or emulsifying agent in food industry. And personal care products. So this polyvinyl alcohol can be found in personal care products such as like shampoos, hair sprays and lotions. In this case also, in this preparation purpose also, we are using this polyvinyl alcohol. And cast and mold releases. So this polymer used in mold release agent for various casting applications. It's including ceramics, So including ceramics and composites. In this case also we prefer this polymer. And next one, water treatment. So this polyvinyl alcohol is used to remove impurities. And suspended solids from water in wastewater treatment process. So water treatment purpose also we prefer this polyvinyl alcohol polymer, because this when we are using this biodegradable polymers, it removes impurities and suspended particles which are present in water. This is mainly preferred in wastewater treatment. In this case, we prefer this type of polyvinyl alcohol polymer. And 3D printing. So it is employed in 3D printing as a water soluble support material for complex geometrics. So in this purpose also we prefer this polyvinyl alcohol. So in this class we learned about what is biodegradable polymers, classification of biodegradable polymers. It is classification based on structure, origin and application oriented. So in this case we divided biodegradable polymers, and these are having so many properties. So best example of biodegradable polymers are polylactic acid and polyvinyl alcohol. So in this class we learned about how can we prepare this polylactic acid and polyvinyl alcohol preparation, properties, uses also we will learn in this session. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.